Hello everyone, hope you're doing well. Welcome back to Thinking in Pine short video series. In last session, we learned about Pine script time series model. Today, let's discuss about some special cases of time series variables. If you have not watched our last video on time series, please stop here, take a step back and watch the video. You can find the link to the earlier video on time series in the description or in the linked ideas section. That said, let's not waste any more time and let's get started. The cases of time series that we are going to discuss today are like how the time series variables behave when it is defined under an if condition or when it is defined within a loop. So let's take a look at it by through this program. So in our last video we have learned that we can access historical values of a variable using the historical value operator. So with the brackets, with the square brackets, if you refer to a one like historical the variable of one, then it is the last bar value, and if it refer to the value of 500, it's the value which is 500 bars before. So having said that, this is not always true. So in this case it is true because the variable is declared in the global scope. So when the variable is declared in the global scope, this code runs through every bar. That's why we can safely say that a current bar of 1 here refers to the previous bar value. But what happens if the variable is defined in an if condition? For example, look at this if condition. So this condition runs once in 3 bars, right? So when the bar index percentage 3 is equal to 0, that's when this code runs. It means that special bar index here gets assigned only when bar index star 3 is equal to 0. So due to this series will not have the value for all the bars. So it will have value something like this: 0, 3, 6, 9, 12, and so and so. So when we print this value, so this logger, what it does is it actually prints the last instance of special bar index and the previous instance of the special bar index. So when you print this, what you get here is definitely you will get the last bar index, but the for the last but one value, it is something which is 3 less than the last value. So it is not actually previous bars value, but it is the previous assigned value to this variable. So let's go to the logs and see how it looks. So you can see that the last bar value is 26178 special bar index, and then the previous value, the previous historical value here is 3 less than the last value. That is because the assignment itself happens once in 3 bars. So this is no longer at the previous bar value, it is value which is assigned 3 bars back, right? So why this is important? Because of this, we cannot use the functions, or we cannot use the methods, the built-in functions, or user-defined functions that requires historical operator for calculation of something. For example, if you try to calculate SMA here, SMA 20 is equal to ta dot SMA close and 20. So you do this, what happens is it gives a warning here. You can see that um, the function SMA should be called on each calculation for consistency. It is recommended to extract the call outside from the scope. That means that whenever you have something like this, you need to have this call in the global scope instead of in under the if condition. Because when you run this code once in 3 bars, what happens is it will not calculate the simple moving average for the close price. It will actually calculate the say the series with with intermediate values. So it will calculate the average from close of 0, the close at 0th bar, close at 3rd bar, 6th bar, and all, and this way. So it will actually try the average with the intermediate bar, intermediate once in 3 bars value. So because of that, you cannot use the functions like this within an if condition. You have to always do it in the global scope. Okay, so this is how a time series variable works when you define the variable within an if condition. So now let's take a look at the second condition. So this is our first case. So let's take a look at the second condition. So this is the second case of using it in a loop. So here what we are doing is we are defining two arrays, array of x and array of last x. Okay, And what we are doing here is from I is equal to 1 to 5, x is equal to I star 10. So like the it will run through a loop from 1 to 5, and x will have the value like 10, 20, 30, 40, and 50. So what I'm doing here is array of x dot pushes x. Push x means every value which I'm deriving here, I'm pushing it to x. And then I'm also pushing x of 1, means the historical value of x, right? So when x is equal to 10, they like in x I is equal to 1, x is equal to 10, and I is equal to 5, x is equal to 50. So that is fine, there is no problem here. But how will it behave when you try to catch x of 1? Means the last bar of x which is in the last bar. So let's check this. Say let's save this and run it on the loop. Okay, so you got the values here. You can see that. Okay, I made a mistake here. It has to be 0. 0 here. Okay, so you can see that the array of x contains 10, 20, 30, 40, and 50 as expected, right? But array of last x all contains 50. Why is this? That's because when you run in a loop, x goes through multiple assignments. Like on a first iteration, x is equal to 10. On the second iteration, x will be 20. And similarly, on the fifth iteration, x is 50. So when this loop is completely finished, the value of the last value of x is 50. That's why when you run in the next bar, x of 1 always equals to 50, irrespective of what current value of x is, right? So this is why we should not use, again you can see the warning here. So it's declared in the local scope, which may not be executed on every time. So so obtaining its historical value may lead to unexpected results. So that's why we'll not be able to use historical value of a variable which is defined within a loop as well. So the main use case is, I tried to do something like this during my initial days. For I is equal to 20 to 100 by 20 means 20, it will run for 20, 40, 60, 80, and 100. I try to calculate SMA is equal to ta dot SMA of close and I. So again, this will not work properly, again because um, the SMA function uses historical values, values and all. So because of this, the I is always changing, and it doesn't give you a proper value of it doesn't give you the proper output or expected output for SMA in this case, right? So whenever you use, again, the crux of this is same as in what we discussed in the if condition. But we discussed what needs to be done in the if condition. We cannot use any functions using the variables of the loop, or using the variables which is defined in the loop, which use the historical operators, historical values. So again, so just make sure that you do not use any functions within the if conditions which use historical operators and the variable defined in the local scope. That's all. And these are the two special cases I wanted to discuss today. Hope you learned something. Thanks very much. Please let me know if you have any questions. And that's all for today. Goodbye. Thanks.